Hello everyone, my name is Dr. Muhammad Amir and I am the CEO and founder of Unite, Authien and Beliix. Today I'm going to be talking about bypassing the next generation 2FA and MFA implementations. First of all, I would like to thank the team of HackGDL and the InfoSec community in Mexico for giving me a chance to speak at this amazing conference. I apologize due to logistical reasons beyond my control. I could not be there physically, but I have made this pre-recorded video for you all to view and learn from, and I will be available after the presentation for a question and answer session as well. Let's get started. A little bit about me. My name is Shahmeer. I am the third ranked bounty hunter. I've hacked into 500 companies ethically. I'm the CEO of Unite, Authien, and Beliix. I've written a couple of books. I am a PhD in applied blockchain security. I am an MSc in cybersecurity as well. Agenda. 2FA, how it evolved into MFA, implementation of 2FA and MFA, bypassing 2FA in web and mobile applications, bypassing MFA using logical flaws, bypassing Android and iOS biometrics authentication, and bypassing mobile application MFA. We're going to look at all of these. Let's see how much time allows us in terms of going through all of these points. Here's a little disclaimer here. Whatever I show in this presentation and talk, it's for educational purposes only, but you can do with it as you wish. And I would recommend utilizing this knowledge in bug bounty hunting and in your practical experiences in order to move ahead.2FA. 2FA is two-factor authentication. It is an identity and access management security method that requires two forms of identification to access resources and data. It's basically someone came up with an idea that there should be another password on top of the existing password, but the only difference is that the second password should be time-based, and they came up with a word called 2FA. And then someone came up with an idea of making those time-based passwords tied to biometrics or hardware systems, and that became MFA. That is basically the gist of both of these technologies. Let's look at the 2FA's working architecture. Basically, 2FA has 4 steps. One is application authentication, second is the logging mechanism, third is the OTP generation, fourth is the OTP delivery. Let's look at the implementation of 2FA. So you can combine the implementations of 2FA into these 8 methods. You have SMS, you have time-based, you have push notifications, you have challenge, you have email, you have FIDO, and you have biometrics. Now, if we were to attack 2FA in web and mobile applications, I believe that based on my research, there are 10 methods that one can use to attack 2FA. And we are going to look at all of these methods recursively. You're going to need a couple of tools with this. One is a client-side proxy, the second is the word list, the third is a proxy server list file. Let's look at the first attack vector. The first attack vector is called brute force. Brute force attack, as you all know, it is a type of a guessing game where the attacker tries to guess the correct passcode or the correct sequence. It is easier to do if the codes are 4-digit, but it is more difficult to accomplish if the code is 6 digits or longer. The longer the authentication, the better for this type of attack is, basically. Let's look at this one, bypassing grab. It's basically an API called brute force. Profile activation code was the parameter that was required to be brute forced. And upon successful attempts, the content length actually changed to the HTML page, and we were able to detect that using the burp intruder. And this is how we bypassed 2FA and grab. It was a very widely accepted case study scenario, and it was very, very appreciated as well. Conventionally, we have cases like Slack as well, where rate limitation on 2FA is on one page, and while on the other page there is no rate limitation on 2FA. So in this particular case, the Slack app had 2FA brute force protection on the main page, and Slack did not have 2FA brute force protection on the secondary page. Then this is what happened was user basically requested a password reset token, and they resetted the password, and then they were redirected to a 2FA page, which did not have 2FA brute force rate limitation. Then this was a very peculiar and a very nice case as well. It was in Dashlane basically. This was a very well protected 2FA page in terms of brute force, but what they did not have was protection against the header manipulation, which we used to bypass the 2FA protection mechanism here. The X forwarded for header, it's basically a method using which the attacker can bypass the throttling completely. The X forwarded for header is basically a redirection header that allows that basically identifies the source and the destination IP address. In this case, when we added 127.0.0.1, it meant that the request was originally coming from the server itself, and we were able to bypass the rate limitation by simply adding that header, and we were able to bypass the 2FA brute force protection. This one was very interesting. Basically, Microsoft, as you know, is a very widely. It has its own authenticator. It has its own. It's a giant. We all know that. Me and a buddy of mine called Zero Hack. His name is Lakshman. We were able to bypass Microsoft's 2FA. Basically, he was the one who did it. Most of the work, he was the one who did it. I just, wrote the article about it. So kudos to him. The 2FA limitation protection was based on IP address blacklisting. Now, this was very, very fun to do because this bypass basically consisted of sending all of those requests concurrently at the same time, with no more than a 10 millisecond delay. So there were two vulnerabilities that incorporated in this. One was that Microsoft was not basically identifying if the IP address is a decoy or not. The second one was Microsoft was not identifying if there were concurrent requests on a single account or not. So what we did was we came up with a scenario where we were able to create 11 million fake IP addresses and concurrently bombard a single account with those decoy IP addresses, and in the response we got it was basically IP-based rate limitation, not an account-based rate limitation. So we were able to bypass the Microsoft 2FA. Yeah, this one was very interesting as well. This was a 2FA bypass within Facebook's architecture. So Facebook has a donate option, right? And this was funny because if you copied that donate link from one device and pasted it into another, you basically logged into Facebook. I'm not even joking. So if you had one account where you would just go in and somehow get the href behind the donate button, and you would paste that into another web browser somewhere else, you could easily log into that particular victim's account without even having a password. more or less 2FA. And then came Mapbox, one of the biggest map solution providers. The Mapbox password reset session, it was broken in a way that the attacker required access to the user's email account, logs the user in, but it is not prompted to a 2FA code. So this was basically okay, hold on, I think I missed it. It was we're in broken session management now. Sorry. This was not brute force. This was broken session management. This was a session flaw. This was brute force. This was a session flaw. Sorry about that, guys. So yeah, let me tell you a bit about broken session management before we move ahead. Broken session management is a session-based flaw where you are required to where you can basically log into a user session at a point in the login process where you're not supposed to log in. IDORs are a great way to iterate broken session management. We have different other scenarios which are a great way to iterate broken session management as well. And most of these ways depend on one way or another. Most of these ways depend on basically either acquiring access to some kind of link or acquiring access to some kind of session cookie or not. As we talked about in Facebook, this was a very widely accepted broken session management flaw, and we talked about in Mapbox here, if a user basically reset another user's passwords or somehow got access to the password reset link, they would log into the user account even if the 2FA code was implemented. Similarly, we have had cases in Instagram where a user can set 2FA to secure his or her Instagram account so that no one can log in essentially to their account, even if they have the login credentials. This vulnerability basically allowed attackers to bypass 2FA, and the missing checks were in place where the user uses the secure account here option from the email changed a notification. And this was basically the flow that was in Instagram. User B basically logged into user A's Instagram account. User B replaces user A's user A's email with its own email address via the edit profile option. User A, who is the victim, gets this unrecognized email, and user A goes to the login activity and revokes the session. And then user A changes their account password. User A then replaces the unrecognized email address from his profile with his own email address. User A now sets 2FA security for his Instagram account. Then user B gets an email changed to notification in their email. And user B basically clicks on the secure account here option. User B may be asked to verify if a@gmail.com belongs to him, which he verifies using user A's email credentials, and user B successfully bypassed 2FA there, thus creating an active user A session without any kind of 2FA check. And this was the video that we had in Instagram. Oops. So let's move ahead. Let's look at CSRF. We know what CSRF is. It's basically cross-site request forgery, in which an attacker forces a victim to click on a link that is internal and that is not basically visually visible to the victim itself. This form of attack is very popular in 2FA bypasses because it can be used to disable 2FA. Similarly, in this case, the website called MailRU, there was a website under its acquisition model called handout.ru, and basically, but this website was missing 2FA protection on its page where a 2FA was to be disabled or enabled. It was very, very easy to bypass that. In order to, we save the CSRF POC with the extension .html, and then we log into the victim's browser account and force the victim to click on that particular link, and their 2FA would be easily disabled. Similarly, we have something called code reusability. This is a technique where the attacker reuses a certain or a particular code after acquiring it, and and they reuse the code after a certain period of time. This particular scenario was in a website for WordPress.com, and then we navigate into the settings and enable the 2FA. We save the code, we log out, and then we can reuse that code as many times as we want because the 2FA enabling code was not expiring. This is another, and I think we're running a bit out of time here. This is another very interesting scenario. It is called the 2FA code leakage. This is a scenario where the 2FA code is leaked in the application responses or internal files. And as you can see here, that bypassing the apps 2FA, leaking in the HTTP responses right here, that once you go ahead, this was an app that we can name, obviously. Once you go ahead and enable the 2FA code, or you were able to request a 2FA code, the 2FA code itself was generated from the client side and then being sent in that particular request, so you could intercept that request and acquire the code. And this was another very interesting scenario, and I want you all to pay attention to this because I'm going to spend a little bit of time on this. 2FA, the mechanism of tying an authenticator application with an account is basically based on a secret key. This particular secret key is of value, and it is unique for all users and cannot be brute forced. Basically, if someone can get access to this particular secret key, they can bypass any user's 2FA account fairly easily. In this particular system, what the problem that we were having was we were able to see the secret keys of other users in the responses, the users in our organization, to be fair, but still other users, and their secret key was visible to us in responses. And this particular scenario was that we took those secret keys and we generated QRs from them, and then when we scanned the QR using authenticator apps, we could connect to their accounts, and we could bypass their 2FAs fairly easily. As you can see here, this is another secret key that is being disclosed. Input parameter poisoning is an attack evasion technique. This is also very interesting 2FA bypass scenario. It's called an input parameter poisoning, and IPP is basically an attack vector where an attacker basically crafts an HTTP request in order to manipulate or retrieve information. Retrieve information in a way that the server doesn't know. For example, in this particular scenario, we had Glassdoor. And when you went to Glassdoor, you enabled 2FA, you logged out and log in, and you notice that the OTP is asked, just like in any other scenario. But the simplicity of this is we removed the parameter itself. We just removed the 2FA code and replaced it with null characters, and we were able to bypass the 2FA fairly easily in this case scenario. Similarly with PayPal. Now this was a very interesting and another very peculiar scenario where the attacker basically logs into the account and selects the CIT option to log in, which is another way where you need to answer some of the questions that you initially answered. What we did in this particular case was very interesting. We basically removed the challenge and response fields entirely from that request. So this was not a code-based 2FA. It was a 2FA that was based on challenges and responses, and we completely deleted those challenge and response fields. And we were granted access into the victim's PayPal account, and this didn't even ask us for the password. Now another technique is called response manipulation, and this is another very interesting technique where you are able to manipulate a response that is coming from the server. The simplest way of response manipulation is, as you see in this scenario, and this applies to not only 2FA but other attack vectors as well, where you are able to, if you enter a wrong 2FA code, it would return false. If you entered a correct 2FA code, it would return true. And the account with the 2FA authorization would receive a similar response. It would be false, and then it would receive a response that is true. And if you would just change false to true, you were granted access. Taking it to another level would be that checking here if the response of the login request was correct or not. This website basically uses an authorization token, and this token is provided only if the 2FA step gets completed, which is the authorization bearer. We all know that, right? In this particular scenario, you can see that first of all, this was also an unknown site. We enter the user ID and password, and then we get an OTP, we save the successful response of that OTP. And then once we log into the victim's account, we obviously don't know the OTP, and so what we basically do is we replace the successful OTP response with the false one in that particular step, and in this way we are able to bypass the 2FA with little tidbits of changes, of course. For example, the session cookie would essentially be differentiated. The session cookie, the MFA value in the session cookie would also be differentiated as well, and in this scenario we can go ahead and bypass it. There was also another, very interesting scenario where we were able to bypass 2FA in the local Pakistani e-balling system, and this would be the last slide of the presentation. I think this would, end our session. So I'm going to show you this very interesting video, and here what you can see is in this. We were able to initially acquire the encryption key from the application. It was hard-coded. They were using this encryption key to intercept, to basically encrypt requests and responses. What we did was we acquired the encryption key and we got the UID of the user. We decrypted a couple of responses, and we found out, okay, this particular response means this, and we were able to consequently encrypt those responses as well. Once you try to activate this particular wallet, what you can see is that it's successful, but then you try to enter the OTP, it's not successful. What we did was we acquired the successful responses, and then we changed those successful responses based on each user's UUID, and we were very much able to bypass the 2FA of that particular account, and this is what is being shown here. This was a salted AES encrypted version of the file, and we were able to successfully bypass the OTP using this particular scenario and situation. We're replacing the responses, and it will just it's successful, and then we're going to replace another response, and it's going to be successful as well. We'll bypass the OTP here. It was very interesting. It was a 5-step bypass, and they had to change their entire authentication mechanism because of this. Whoops. We we had to change the response. See? Bypassed. Yeah, we are mostly out of time here, guys. It's already been 30 minutes, and we have to leave window for question and answers as well. I think that it has been a great session with you all. I think that you all were amazing, and very patient in listening to me virtually. I can make out the faces and the scenarios that you guys are currently going through right now, and I'm very, very thankful to all of you for giving me this opportunity to present to you today, and I will hopefully see you in next year physically in Hack GDL. You guys can connect to me on LinkedIn. You can email me if you have any questions about this presentation. You can get this information from the organizers. Thank you so much, David. Thank you so much, everyone else who helped organize this event. And I will see you all very, very soon. Bye.